Said you had $10, and then I said, I'm going to double that. How much money do you have? $20. How did you get $20? Multiply it by 2. So we can take some amount, and we can multiply it by 2. We can multiply by 2, and that doubles the quantity. How else could you think about if you had $10, and I'm going to say I doubled that, rather than multiplying by 2, how else can we double a quantity? Yeah, add it to itself. If you had $10 and you add another $10 to it, you're doubling your amount. So, you can write that as A plus A. Okay, doubling a quantity is multiplying by itself or adding it to itself. You can do either one to double that. Well, what we're going to talk about today is the double angle. The double angle. The 2A. When I have 2A here, A is any angle. And if I have 2A there, I have the sign of a double angle. Because we just said mathematically we could double it by multiplying by 2. Well, that's what this is, multiplied by 2. But what we also wrote this as is the sign of A plus A, which is angle addition. So what I want you to get your formula sheet out again, because we're dealing with angle addition, you have on your formula sheet the sign of A plus B. Well, what I want you to look at now is expanding out the sign of A plus A, but now you don't have a B there, you replace the B with another A. What you have in your formula sheet is you have A plus B, but I don't want to write a B because we have an A there. So expand that out. Write out, expand out the sign of A plus A. Using sines and cosines, and now you're only using A's. You're not using B's. You're just using A's. So rather than saying sine A cosine B plus the cosine of A sine B, well, now we have sine A cosine A because B has just turned into A. And what you should have wrote is sine A times the cosine of A, because B is now turned to A, plus the cosine of A times the sine of A. Does x times y equal y times x? If I take 5 times 4, does that equal 4 times 5? Yeah, it's called the commutative property of mathematics, of multiplication, my bad. Commutative property of multiplication. So if I have two things being multiplied together, it doesn't matter which one comes first, which one comes second, I can switch it. So we can write this as a sine of A times the cosine of A, plus another sine of A times the cosine of A. Now let's go back and look at our algebraic idea. If I have xy plus another xy, xy plus xy, what does that give us, Kendall? Not x squared y squared. No, 2xy. This gives us 2xy. Well, I have sine A cosine A plus another sine A cosine A. So what that will give us is that will give us 2 cos 2 sine of A times the cosine of A. So your sine of a double angle can be calculated 2 sine of A times the cosine of A. Once again, nothing big to add to your sheet. Cosine 2A can be written as cosine A, cosine A. So expand that out. We have cosine of angle addition. Okay, combine your two cosines together. You have cosine A times the cosine of A. What's that give us? What's x times x give us? Well, what's cosine times cosine give us? What's sine times sine give us? You have two. Now, we're not adding these together. We have two of them that we are multiplying together. Vic, what do you have?
Sine squared A minus sine squared A.
We have cosine squared minus sine squared. So your cosine double angle is cosine squared minus sine squared. That's the one I suggest that you use. Okay, you have two offshoots of this. Because what we learned is that sine squared, from what we just talked about, sine squared is equal to 1 minus cosine squared, or cosine squared A is equal to 1 minus sine squared of A. It's what we dealt with in last section. My suggestion is you default to this. When you're finding the cosine of the double angle, go cosine squared minus sine squared. But you can also replace your cosine squared up here with 1 minus sine squared. So we have 1 minus sine squared minus another sine squared, which gives us 1 minus 2 sine squared of A. And we could also replace the sine squared with 1 minus cosine squared. So we have cosine squared of A minus 1 minus cosine squared of A. We can distribute the negative through. So we have cosine squared A minus 1 plus another cosine squared. So we come down to 2 cosine squared of A minus 1. So all three of those are cosine of double angles. We will use the next two, the bottom two, to prove our half angle formulas come Monday. Once again, my suggestion, when you have a cosine double angle, default to the first one. But we will utilize the bottom two ones when we prove something else next week. Tangent 2A is tangent A plus A. Go ahead and expand it out again. Cosine A plus A. your angle addition formula and expand them out, or this out. Then the top, combine the two things on top. Then on the bottom, you have something you can combine on the bottom. Now we'll give your tangent at 2a. Tangent A plus tangent A, Brianna, what do you come up with?
2 tan A and then 1 minus 2 squared A.
We have 2 tangent A on top, and tangent A plus tangent A gives us 2 tangent A. Tangent A times tangent A gives us tangent squared A. And likewise, like before, the cosecant of 2a is 1 over sine of 2a. The secant of 2a is 1 over cosine of 2a. And the cotangent of 2a is 1 over tangent 2a. So you can look at your reciprocal functions and find your double angles of your reciprocal functions. You find your first values, and then when you get done with it, you flip it over. Tangent of angle A is 4/3 in quadrant 13, or quadrant 13, quadrant 3. So in quadrant number 3, we're going to draw tangent A. Why? Because it says so. The tangent defined to us as opposite over adjacent. We are going to see the same types of problems again. Once again, that's why students tend to do a little bit better on this one, because they're a little bit more used to the types of problems that you have. So my opposite side is 4, my adjacent side is 3. So throw in your values. Pythagorean triple, we have a value of 5, and we check for any negative signs. Do we have to throw any negatives in there, Vic?
-3, -4.
Yeah, both of these left and downwards. So the tangent sine of 2a. Expand it out to sine A times the cosine of A. So I go out to my triangle. What is the sine of A? What is the cosine of A? And then we multiply our fractions. The 2 we can write as 2 over 1. To make that a fraction. How do we multiply fractions? We multiply all the tops, and we multiply all the bottoms. Find the sine of 2a and check the answer for somebody around London, what's the sine of A?
Sine of A is negative 4 over 5.
What's the cosine of A?
Negative 3 over 5.
Okay, so we multiply across our tops, multiply across our bottoms. What do you come up with?
24 over 25.
24 over 25. Cosine 2A. Once again, my suggestion to you is you default to this. The reason why is you have two numbers you're going to have to multiply or add together. To add numbers, you're going to create fractions. To add fractions, we have to have a common denominator. What this will give us is this will give us a common denominator. We won't have to work too hard then. This will give us automatically, because our hypotenuse is going to be in the bottom of this. So, what's cosine of A? Find that value. What's the sine of A? We just did that up top. Square both of those fractions, and then subtract them. Well, to subtract fractions, we have to have a common denominator, and we automatically will get that common denominator with our two fractions. That's why I say my suggestion is go ahead and use this. If you use 1 minus 2 sine squared or 2 cosine squared minus 1, that 1 doesn't have a common denominator for you. Then you have to do a little bit more work. The negative 3/5 and negative 4/5 we just did up top. Cosine was negative 3/5, sine is negative 4/5. Square all the quantities. Now remember, when you square negative, you get a positive. So we should get 9 over 25 with the first, 16 over 25 with the second. We're subtracting them. What do we come up with then? Trenton, what do you get? Negative 7 over 25. Tangent 2A. Now, what I suggest you do with the tangent of 2A is, yes, we have negative 4 over negative 3, but what happens to two negatives? They cancel out. So the tangent of A still comes out to positive 4/3. So my suggestion is, when you have two negatives in there, cancel them out and get rid of them, because all that will do is that will do that to your brain. Okay, that will tend to confuse you because you throw the negatives in. So I would suggest you go back just to the 4/3. Now on top we have 2 times 4/3. That will give us 8 over 3. On the bottom I can square my bottom. I have 16 over 9. Now once again, if you want to, you can quantify the top, divided by the quantity of the bottom, hit your math button, hit enter, and it will simplify your fraction for you. So we have quantity 8/3 and quantity divided by quantity 1 minus 16/9. Enter your quantity, hit your math button, hit enter, and that will give you back to your fraction. Yeah. Yeah. You have 1 minus Kaylee up top on the front. If you want to, once again, if you want to advance yourself, you get a common denominator, you multiply through by 9. So on top we have 8 times 3. On the bottom we have 9 minus 16. So we have 24 over -7 or -24/7. Or if you click the calculator calculator, you should get the exact same solution. Two sine theta cosine theta equals 1/2. If we have 2 sine theta cosine theta, what one of our double angles is this? 2 sine theta cosine theta. It's one of our double angle formulas. Which one is it? Sine 2 theta. So this gives me sine 2 theta is equal to 1/2. Now we're into the solving the equations. Just like when we had sine theta cosine 20 plus cosine theta sine 20. We could take this back into the sine of theta plus 20. While here we have 2 sine theta cosine theta, we could take that back into sine 2 theta. Now we have to get rid of sine. So how do we get rid of sine? Inverse sine. So we take the inverse sine of 1/2. And we should get a value of 30. But we have a second solution. Take the inverse sine, you get the calculator value, which you just have. And then it's what? Inverse sine. Principal value and its supplement. What's the supplement to 30? 150. We can divide by 2, by 2, by 2, by 2. Theta equals 15 plus or minus the period n. Here theta is equal to 75 plus or minus the period n. Our b value turns into 2. So the period is equal to 360 divided by 2, or 180. Once again, these are problems, typical problems that we did with angle addition. We now just are dealing with double angles. So once again, your comfortability should be a little bit better with this out because it's not new. We've done that. Hopefully, it's a little bit calmer for you, and you're not sitting there going, "Oh my gosh." You might still be saying that, but at least it's not a light speed, Buzz Lightyear's light speed of doing it. It's more Woody way of doing it, a little bit slower pace. Right, solution, homework, page 132, 133, 9 to 30, multiples of 3. Monday's the half angles, Tuesday sums of products. And then we'll look at hopefully a quiz next Friday over this material. Once again, once I get to this point, I try to push my foot down on the gas pedal a little bit because I want you to be able to get through this stuff. Because the quicker you get through this, the more happier you are. So, I understand that.